In this video, I'm going to show a second example of how to apply the average velocity equation. So in this problem, I'm going to have a car, again, our physics car, and it's going to make a trip. And there'll be two parts of the trip. The first part of the trip, we're going to cover a distance of 40 kilometers. So x1, our first part of the trip, is 40 kilometers. And our second part of the trip is also going to be 40 kilometers. However, what's different here is in the first part, we're going to travel a velocity of 30 kilometers per hour, an average velocity. This is the average for the first part. And the second part, it's going to have an average velocity of 60 kilometers per hour. So twice as fast. So we're going to speed up right when we get to the midway point. Okay. And so what we're going to find for this question, or what we're asked to find, is the average velocity for the entire trip. And B, we want to graph the position versus time. All right. So before we get started here, you might be tempted to say, well, the average velocity, if you take the 30 and add it to the 60 and divide by 2, which would be 90 divided by 2, or it would be 45 kilometers per hour, that actually would not be right. And the reason why it wouldn't be right is because we're not sure, even though the distances are the same, we're not sure we're traveling these velocities for the same amount of time. In other words, we may be traveling this 30 kilometers per hour for a longer time than the 60, therefore bringing the average down. But we're going to calculate it exactly, and we'll compare it to what some people would think would be just simply divide by 2, add and divide by 2, or 45. So let's try it. So the average velocity equation is delta x over delta t. Our variables are average velocity, which we do not know, the change in displacement, and the change in time. We don't know this, we're trying to find that. Our change in displacement or position, how far we travel, is 80. It's the 40 plus the 40. We travel 40 and another 40, so a total of 80 kilometers. And the total time we actually don't know. We know that there are two intervals, and the total time, though, is going to be, which we're going to have to find out, is the sum of these two times. The time during the first interval and the time during the second interval. So we need to find those. So we actually do not know that. So that's the problem here. Solve. So let's see. How are we going to do this? If I know that this is the change in position versus the change in time, this is 80. I know on top. And on the bottom, like I said, it's the first time plus the second time. So we need to find these two times here. If I can find those two times, I can plug them in, and I can get my answer of so many kilometers per hour. So how are we going to find each of these times? Well, what we can do is we can consider this a mini problem. We can find the time in this interval, since I know the distance and the velocity here, using the average velocity equation. So let's see. T1, if I rearrange and solve for t here, it's going to be the change in x over the change in over the velocity, which is 40 over 30, which is 1.33, and our time unit is hours, so this is hours. Our time 2 is going to be the change in position, or the second one, which is also 40 kilometers, but at a higher rate, 60 kilometers per hour, and this is equal to 0.667, or 66 repeating, hours, a little over half an hour. So this is basically, we've got the time, and if you do the math here, this becomes 40 kilometers per hour, which, again, if you compare it to the calculation of adding the two and adding these two numbers and dividing by 2, it's 40, which would be 45. The 40 is less than the 45. And why is that? Well, if you look at the numbers here, we're actually traveling 30 kilometers per hour more time than the 60. So if we're at this velocity for a longer time than this velocity, you would seem like it would bring the average down, and indeed it does. It brings it down to 40 kilometers per hour. So that does make some sense. If I want to graph this now, what does the graph look like? So I'm going to graph x versus time. So I'm going to draw my x versus. Remember, when you draw graphs, when they say something versus something, the first variable is always the dependent on the vertical axis value, and the second is the independent or the horizontal axis quantity. So whatever we ask you to graph, it's when you say x versus t, it's this axis versus this axis. So to map this out a little bit, I'm going to go 2 hours here. This is in hours. 1 hour here. And this is going to be x in kilometers here. The unit here is kilometers. So 80 is here. And the halfway point is approximately there at 40. So how do we graph this? Well, let's see. It takes me 1 1/3 hours. So the 1 1/3 I'll say is over here somewhere. 1.33. So I'm going to draw this line in here. So it takes me 1.33 hours to travel the 40 kilometers. And then, if I map this point over here, I get a higher slope line to travel the remainder of the trip, which is the 0.667. So here you can see that I have a low sloping line, which is the 30 kilometers per hour, and I have a higher sloping line that is 60 kilometers per hour. So what is this 40? 40 is taking the 80, value of 80, and dividing it by 2, the total time. And what that is a line that goes through here, I missed it. A line that goes through here, through the origin. One more time. Here, through the origin. I got it close enough that time. So you can see here, what this average velocity line does is it gives us an average slope. Here we have a lower sloping line, so we're going about 30. Here we're going a higher sloping line, or 60. And this average velocity over the entire trip, the slope is 40. So that gives you a visual representation of the average velocity versus the velocities for each of the time periods. So this is another way to calculate average velocities, dispelling the thought that you can just take two velocities, add them, divide by 2. The only case you can do that is if we know that they're acting for the exact same time frames, which we actually don't know. Draw a picture and review. Write down our find, list the average velocity equation, our variables. In this case, we had to actually go back here and do a couple little side calculations, I call them, some side calcs. Find the two times, plug them in, and then we can arrive at our final average velocity.